Hello everyone, welcome to the .NET office. Have you ever heard the saying, big things have small beginnings? Well, imagine a tiny software bug, so small it was hidden deep inside millions of lines of code, managing to disrupt thousands of services, break major websites, cause massive slowdowns, and practically shake the internet. This is the story of how AWS DynamoDB, one of the most reliable databases on Earth, suffered a massive outage in the US East 1 region, all because of one tiny logic flaw. And more importantly, we'll break down what exactly went wrong, how AWS fixed it, and what the cloud industry learned from it. Let's jump in. Before we talk about the failure, we need to understand what DynamoDB actually is. DynamoDB is AWS's fully managed NoSQL key-value database. It's designed for extreme scale, huge throughput, and almost perfect availability. So, DynamoDB, it actually powers a ton of things you use every day. We're talking about banking systems, e-commerce shopping carts, gaming leaderboards, and even IoT platforms. It's kind of everywhere. Even parts of Amazon's own retail operations rely on DynamoDB. So yeah, when DynamoDB hiccups, the entire internet feels it. On the day of the outage, developers across the world suddenly noticed something strange. Applications that normally responded instantly were timing out. API calls were failing. Dashboards showed massive spikes in errors. It was honestly total chaos. And this wasn't a small regional glitch. The entire US East 1 DynamoDB environment was struggling. At first, even AWS didn't know what was happening. The symptoms pointed to internal congestion. Something was overloading DynamoDB's internal communication, but the cause wasn't obvious. A few days before the outage, AWS rolled out a new internal feature to DynamoDB. This feature wasn't something customers would notice. It was an internal optimization to help improve communication between DynamoDB storage nodes. Think of DynamoDB as a huge cluster of tiny machines all talking to each other. This new feature improved coordination, status reporting, and health checks. But there was a hidden bug, a very small one, sitting inside the message handling logic. Everything looked fine when the feature launched. Small-scale testing didn't expose the issue. Even medium-scale tests didn't show anything unusual. But in production, with thousands of nodes communicating, that bug turned into a chain reaction. Here's what the bug actually did, explained simply. One node sends a status message. Another node receives it and tries to respond. Because of the bug, the response triggers another message. That message triggers another response, and it keeps repeating exponentially. This created a runaway feedback loop. Every message caused more messages, and DynamoDB's internal network became a traffic jam. Imagine two walkie-talkies stuck on a loop saying hello, 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 forever. Now multiply that by thousands of machines doing it at the same time. So, this feedback loop resulted in, well, massive message amplification, CPU overload, and network saturation. Replication started to slow down, and even internal control messages began to fail. Eventually, the nodes were so busy shouting at each other that they just couldn't process actual customer requests. DynamoDB, honestly, started suffocating under its own internal communication. In distributed databases like DynamoDB, internal messages are actually more important than customer read and write requests. They control things like leader elections, partition balancing, replication, failure detection, and also consistency checks. But, during the outage, these essential messages just couldn't get through. They were stuck behind the exploding traffic storm. This meant partitions couldn't sync, nodes couldn't confirm their health, replication lag just exploded, and DynamoDB consistency guarantees, well, they broke down. The entire region entered a kind of distributed paralysis. AWS engineers immediately realized something was generating massive internal message spikes. So, they worked through the problem in 3 key steps. Step 1. Stop the storm. AWS temporarily throttled internal traffic between nodes. This acted like putting firefighters between the flames to prevent it from spreading. This didn't fix the bug, but it slowed down the message explosion enough to restore partial control. Step 2. Identify and patch the bug. Engineers isolated the buggy code inside the new feature. They then pushed out a patch to stop the feedback loop from triggering more messages. This patch prevented nodes from replying infinitely to certain types of messages. Step 3 was to rebuild internal tables and stabilize the cluster. Even after fixing the bug, DynamoDB still needed to rebuild partitions, sync replication, rebalance workloads, and restore consistency. You can kind of think of it like repairing the roads after a massive traffic jam. AWS gradually restored normal operation over several hours. AWS made several permanent improvements so that, honestly, this could never happen again. First, they put hard caps on internal message rates. So, even if something goes wrong, message traffic just can't explode out of control. Now, let's talk about the isolation of internal control traffic. Control messages actually have guaranteed priority lanes, which means they're kept separate and can flow smoothly, no matter what. And, there's also better simulation of large-scale message storms. AWS has improved their testing to catch those tricky bugs that only show up when things are running at massive scale. Alright, so, number 4. Multi-layer failsafes in consensus algorithms. DynamoDB now has protection against cascading node responses. Together, these changes made DynamoDB even more resilient. This outage is famous because it showed something super important. In enormous distributed systems, a tiny flaw can behave just like a spark in a giant forest. One small bug can trigger an avalanche of failures across thousands of machines. But it also proved how fast AWS engineers can react, stabilize, and actually rebuild a massive system under extreme pressure. So that's the full story of how one tiny bug managed to crash AWS DynamoDB in US East 1, and how AWS stopped the meltdown before it spread any further. If you enjoy deep, real-world tech breakdowns like this, make sure to like, subscribe, and comment which outage you want me to explain next. There are some wild ones out there. Google Cloud DNS, the Facebook BGP meltdown, the Time.com leap second bug, you name it. Thanks for watching, and I'll see you in the next video.